Hi, this is Vijay Kumar S, a lecturer in computer science. In this presentation, I'm going to discuss about the subject computer science, second PUC, the weightage and the objective based on which the marks has been allocated. And I'm going to discuss something about the first chapter, typical configuration of computer system. As you all know, the subject code is 41. And in the first image, I'm going to discuss the marks allocated and the weightage on particular objective. For example, for knowledge, it's around 30% weightage and the marks allocated is 31 marks. And for objective understanding, the weightage is 40% and the marks allocated for it is 43 marks. And for application, 20% is a weightage and the marks allocated is 21 marks. And for the skill, weightage 10% and the marks allocated is 10 marks. And the second image, you can see the weightage and the marks allocated for the content of the computer science syllabus. The whole syllabus has been divided into 4 different units. Unit A, backdrop of computers, and the marks allocated for it is 31 marks. Unit B, computing in C++, the marks allocated it 39 marks. And Unit C, large data and database queries, and the marks allocated for it 18 marks. And the Unit D, the last unit, the advanced concepts in communication technology, the marks allocated is 17 marks. And the total marks is of 105 marks, and the students are going to attend for 70 marks. This is what about the weightage of the content of computer science syllabus. In the next slide, it's about a blueprint of the old syllabus, entire syllabus, and the marks allocated for particular unit and the marks for particular chapters under that unit. And what I'm discussing, that is chapter 1, typical configuration of computer system, the marks allocated under blueprint is 4 marks. One 1 mark question and one 3 marks question. So you can observe this blueprint carefully. The blueprint is for complete 4 units and the complete syllabus. And the next slide is also about blueprint of units and unit. And we're going to move to the next slide, in which we're going to discuss something about chapter 1, that is typical configuration of computer system. So what and all we are going to discuss under this chapter? First, introduction to computer system, motherboard, introduction to motherboard, types of motherboard, components of motherboard, memory, power supply to the computer system, and assembling the computer system. These are all the content of the chapter 1 we are going to discuss. So generally, when I say introduction to computer system, the image is going to come to your mind. You can see, observe this image. You can see in this image, hard disk drive, optical drive, heatsink, floppy disk drive, motherboard, processor, power supply, and system fan. Everything will be inside the CPU cabinet. The cabinet consists of all these hardware devices. Since processor is a major thing, which is also called as a brain of the computer system, the whole cabinet, generally we are going to call it as CPU. So after this, in the next slide, I'm going to define computer. How do you define computer? Computer is a machine that accepts data as input, processes that data using programs, and outputs the processed data as information. Many computers can store and retrieve information using hard drives. And computers can be connected together to form networks, allowing connected computers to communicate with each other. So this is what about the definition of computer and regarding computer. And the next one, whenever you think about computer system, these are the 4 different things which should come to your mind and which form the computer system to perform the different operations. The first one, that is hardware. Hardware consists of physical devices of the computer. What do you mean by physical devices? The thing which you can touch and feel is called as physical devices, such as keyboard, monitor, printer, processor, and motherboard. Next, software. What is a software? Software consists of set of instructions. The instructions are going to guide the CPU, the task to be performed and how it should be performed. So software is nothing but set of instructions. Next, it is data. Data are the values or raw facts or the raw statistics which are provided as input to the computer. When the processor is going to process the data and provides a result, the result is nothing but output, the data which has some meaning, that is nothing but information. Once the data is been processed by CPU, the result of is nothing but information, the data which has some meaning. The processed data is called as information. Next, users. Overall, the users, people who are going to write the programs and the people who are going to interact with the computer, both of them you can call them as users. On the next slide, I'm going to discuss about the block diagram of computer. Block diagram of a computer. In this image you can observe that there are four different units: input unit, CPU, memory unit, and output unit. The data has been fed to the input unit and it has been processed by CPU, and if you want to store the data, it will be stored in the storage unit, and if you want to output the data, it will be given through output unit. The result is called as processed data, that is nothing but information. You can observe this diagram carefully. And central processing unit, the image you can observe that it consists of control unit, arithmetic and logic unit, and registers. Control unit. Next, in the next slide you can discuss about input unit. What do you mean by input unit? The user interacts with the computer via the input unit. The input unit accepts data from the user and converts it into a form that is understandable by the computer. Computer can understand only zeros and ones, but you can give input data in many forms like word, text, sound, images, document, etc. And some of the examples of input unit: keyboard, mouse, joystick, trackball, microphone, scanner, etc. And the second unit, that is central processing unit. As I already told you, it consists of arithmetic logic unit, control unit, and registers. What is CPU? CPU's role is to control, coordinate, and supervise the operations of the computer. It is also responsible for processing of the input data. So three things which are the major parts of CPU, that is arithmetic and logic unit, performs all arithmetic and logical operations, and addition, subtraction, multiplication, division are the sum of the arithmetic operations. Logical and, logical not, and logical or are some of the logical operations. Control unit. Control unit controls the overall operation of the computer. So it checks the sequence of execution of instructions, controls and coordinates the overall functioning of the units of the computer. For example, in a program, there will be 10 instructions. So control unit plays a very important role in executing the 10 instructions in sequential order. So control unit passes the control signal for the first instruction. Once the first instruction is executed, the control signal will be shifted to the next instruction. So like this, it plays a very important role in executing the instructions in sequential order. And the registers, I told you, registers are high speed storage units which are present within the CPU, and but they have very least storage capacity. So registers are not referred by their addresses but are directly accessed and manipulated by CPU during instruction execution. That is why they are called as high speed storage units, since it is directly accessed by CPU. So next, I'm going to tell you some of the important thing about register. They are referred to as CPU's working memory, and they are used to store data, instructions, addresses, and intermediate results of processing. It is a point to be noted. Sometimes if they ask something about register, you can add this extra points, otherwise not. In the next slide, I'm going to discuss about the next unit, storage unit. Under storage unit, there are two types of memory, that is primary memory and secondary memory. Primary memory is also called as main memory. And examples of primary memory, RAM and ROM. What is RAM? Random access memory. What is ROM? Read-only memory. What are their roles? Main memory stores the data, instructions and intermediate results and output temporarily during the processing of data. So main memory is a temporary memory. So RAM, because whatever you're going to store permanently, you're going to store it in hard disk. So if you open the file from the hard disk, it is going to shift to the main memory. Once you're going to edit some things in that, if suddenly power is off, if you have not saved the things, the whatever you have edited, it won't be updated. So main memory is called as temporary memory. Once you edit the things and if you save the thing, then it will be saved in the secondary storage, that is hard disk. The secondary memory, also called as the external memory of the computer, stores permanently the data, programs and the output. Example, hard disk, CD drive. Still many more examples are there. Magnetic tapes, optical discs and flash drives. And the last unit, that is output unit. The output unit provides the processed data. I told you, once the data is processed, it is called as information. Before processing, the data is stored, and after processing, the data is also stored. So once the data stored will be displayed through output unit. The result generated after processing of data. The output may be in the form of text, sound, image, document, etc. Some of the examples of output unit: monitor, printer or plotter, speaker, etc. In the next slide, I'm going to show you some of the input, output and storage devices. You can observe carefully. There are input devices like keyboard, mouse, output devices like speaker, printer, and storage devices like secondary storage, that is a floppy disk drive, hard disk drive, many CD drive, etc. So in the next slide, I'm going to discuss about motherboard, but in the next video.